Network Interface Cards (NIC). In this video, we are going to learn about network interface cards. A network interface controller is a computer hardware component that connects a computer to a computer network. An NIC provides the computer with a dedicated full-time connection to a network. Personal computers and workstations on a local area network, that is LAN, typically contain a network interface card specifically designed for the LAN transmission technology. Each NIC card will be having its own unique address known as MAC address. MAC address is also called as physical address or hardware address. It has a 48-bit address and is represented as a 12-digit hexadecimal number. Main components of NIC. The main components of NIC are PCI interface, PCI slot, RJ45 slot, Ethernet processor, RAM-ROM socket. PCI interface. A peripheral component interconnect, that is PCI, is a computer circuit board that provides multiple diverse interfaces for connections to external networks. In personal and business computer systems, PCIs can facilitate the use of multiple devices with different cable configurations. PCI card consists of 62 copper pins. Depending upon the manufacturer, it varies. These pins are attached to the slots that are available on the motherboard called as RJ45 slot or PCI slot. PCI slot. The PCI slots are present in the motherboard where the network interface card is inserted. Short for Peripheral Component Interconnect, PCI was introduced by Intel in 1992, revised in 1993 to version 2.0, and later revised in 1995 to PCI 2.1 and is as an expansion of the ISA bus. PCI bus is a 32-bit computer bus that is 133 Mbps, that is also available as a 64-bit bus and was the most commonly found and used computer bus in computers during the late 1990s and early 2000s. RJ45 slot. The RJ in RJ45 stands for Registered Jack, since it is a standardized networking interface. The 45 simply refers to the number of the interface standard. Each RJ45 connector has 8 pins, which means an RJ45 cable contains 8 separate wires. The RJ45 physical connector is standardized as the IEC 606037 8P8C modular connector with different categories of performance with all 8 conductors present. A similar standard jack, once used for modem data connections, the RJ45S uses a keyed variety of the 8P8C body with an extra tab that prevents it from meeting with other connectors. The visual difference compared to the more common 8P8C is subtle, but it is a different connector. The original RJ45S keyed 8P2C modular connector had pins 5 and 4 wired for tip and ring of a single telephone line, and pins 7 and 8 shorting a programming resistor, but is obsolete today. The jack connector that connects both the ends either to a router or switch or in the NIC card. The RJ45 slot helps to connect through the one or more different devices. Ethernet processor. Ethernet is the most widely installed local area network LAN technology. Ethernet is a system for connecting a number of computer systems to form a local area network with protocols to control the passing of information between the systems in the network. As internet link speeds continue to grow exponentially, network servers will soon have the opportunity to utilize 10 Gbps Ethernet to connect to the internet. This type of network was developed by Xerox. It was eventually standardized as the IEEE 802.3 based on the Ethernet DIX standard. DIX is Digital, Intel, Xerox. A programmable network interface card (NIC) would provide a flexible interface to such high bandwidth Ethernet links. Ethernet is generally divided into two types: Fast Ethernet, Gigabit Ethernet. Fast Ethernet. Fast Ethernet provides transmission speeds up to 100 megabits per second and is typically used for LAN backbone systems supporting workstations with 10 base T cards. The goals of Fast Ethernet are as follows: upgrade the data rate to 100 Mbps, make it compatible with standard Ethernet, keep the same 48-bit address, keep the same frame format, keep the same minimum and maximum frame length. Gigabit Ethernet. Gigabit Ethernet provides an even higher level of backbone support at 1000 megabits per second. The goals of Gigabit Ethernet are as follows: upgrade the data rate to 1 Gbps, make it compatible with standard or fast Ethernet, use the same 48-bit address and same frame format, keep the same minimum and maximum frame length, to support auto negotiation as defined in Fast Ethernet. Almost all the implementation in Gigabit Ethernet use full duplex mode. RAM or ROM socket. RAM chips on the NIC serve as a buffer. When the card receives more data that it can process immediately, the RAM buffer holds some of the data until the NIC can process it. ROM only reads the signal and let the connection between server and client operation. Network traffic often travels too fast for more NICs to handle. RAM chips on the NIC serve as a buffer. When the card receives more data than it can process immediately, the RAM buffer holds some of the data until the NIC can process it. RCNET. In this video, we are going to see about RCNET. Attached Resource Computer Network. RCNET is one of the oldest, simplest and least expensive types of local area network. It uses a token bus scheme for managing line sharing among the systems and other devices connected on the LAN. It uses a token ring architecture which supports data rates of 2.5 Mbps and connects up to 255 computers. RCNet was originally introduced as an automation LAN by DataPoint Corporation. DataPoint envisioned a network with distributed computing power operating as one larger computer. This system was referred to as ARC, Attached Resource Computer, and the network that connected these resources was called RCNet. What is token ring? a type of computer network in which all computers are arranged in a circle. A token, which is special bit pattern, travels around the circle. RCNET packet structure. A unit of data transmitted across the network is called a packet on an RCNET network. It contains 3 layers as shown. The header and trailer fields contain the addresses of the source and destination computers with the data between the addresses. The working of RCNET. The RCNET used a token ring scheme for Ethernet, and the token will be circulating in the network. The computer should catch the token to participate in the communication. This means that a machine cannot send or receive data unless it has the token ring. As soon as a computer catches the token, it sends out a data packet into the network. This packet will pass in the network until it reached the destination computer. Then this packet is copied by the destination computer and marked to indicate that the data is reached. The marked packet is then sent into the network. As the source computer gets a marked packet, it releases a new token back into the network. Advantages of RCNET. RCNET is inexpensive and works adequately for small networks. RCNET Plus offers a higher data transmission rate than standard Ethernet. It supports a variety of cable types including coaxial, UTP and fiber optics. Disadvantages of RCNET. RCNET is an older technology that is not as popular as Ethernet and token ring. It is very slow and almost 7 times slower than the token ring. Its networking components are not as widely available, and it is more difficult to find technicians who are experienced in working with RCNET technology. Cabling. In this video, we are going to learn about cabling and their types. Cable is the medium through which information usually moves from one network device to another. There are several types of cable which are commonly used with LANs. In some cases, a network will utilize only one type of cable. Other networks will use a variety of cable types. The type of cable chosen for a network is related to the network's topology, protocol, and size. Understanding the characteristics of different types of cable and how they relate to other aspects of a network is necessary for the development of a successful network. The following sections discusses about the types of cables used in networks and other types of networks. Types of cable: thin Ethernet, thick Ethernet, Unshielded Twisted Pair Cable UTP, Shielded Twisted Pair Cable STP, Coaxial Cable, Fiber Optic Cable, Cat5 and Structured Cable. Thin Ethernet. In this video, we are going to see about thin Ethernet. Thin Ethernet is a variant of Ethernet that uses thin coaxial cable terminated with BNC connectors. Thin Ethernet is also known as 10^2 thin Ethernet. The maximum transmission speed is 10 megabits per second. 10^2 thin Ethernet got its name because the coaxial cable it runs on a thinner than the cable used for thick Ethernet. The name indicating 10 is for 10 Mbps operation, base is for baseband operation, and 2 is for a maximum of 200 meters, actually 187 meters of cable segment length. The Network Interface Card (NIC) performs the functions of a transceiver so that No external transceiver is needed for workstations. 10^2 cable parameters and wiring rules. Maximum length per segment is 185 meters or 607 feet. Maximum of 30 stations per segment are allowed. Bus topology NICs come with built-in transceivers, so connections are made directly to NIC via T-connector. T-connectors must be plugged directly into NIC. There cannot be any cable between T-connector and NIC. A minimum of 0.5 meter or 1.6 feet is allowed between T-connectors. B and C transceivers cable must be used on NICs that do not have built-in transceivers. External transceivers must be placed at least 0.5 meters or 1.6 feet apart. Both the ends of the cable segment must be terminated with a 50 ohm terminator. One end of the cable must be grounded. The other end must remain ungrounded. Terminator must be attached to open jack of T-connector at both ends of the segment. Do not attach terminator directly to cable without T-connector. Repeaters may be used to extend the signal. Maximum of 2 repeaters may be used between devices. Properties: the length of each segment in thin Ethernet must be greater than 0.5 meter and less than 185 meter. Up to 13 nodes can be attached in one segment. Advantages: it is very thin, flexible and easy to handle. No need for external transceivers and AVI. Disadvantages: a 10^2 segment is easily and regularly interrupted. Limited segment length, small number of transceivers per segment. Thick Ethernet. In this video, we are going to see about Thick Ethernet. Thick Ethernet was the original commercially available variant of Ethernet. It is also known as 10^5 or ThickNet. This is a stiff 0.375 inch, that is 9.5 mm diameter cable with an impedance of 50 ohms, a solid center conductor, foam insulating filler, a shielded braid and an outer jacket. The outer sheath was often yellow to orange or brown foam fluorinated ethylene propylene for fire resistance, so it often is called yellow cable, orange hose, or sometimes humorously frozen yellow garden hose. Network design: thick Ethernet coaxial cables had a maximum length of 500 meters, that is 1640 feet. The maximum number of nodes that can be connected to a 10^5 segment is 100. Transceivers may be installed only at precise 2.5 meter intervals. This distance was chosen to not correspond to the wavelength of the signal. This ensures that the reflections from multiple taps are not in phase. These suitable points are marked on the cable with black bands. For coaxial cable-based Ethernet, each end of the cable has a 50 ohm resistor attached. If termination is missing or if there is a break in the cable, the AC signal on the bus is reflected rather than dissipated when it reaches the end. This reflected signal is indistinguishable from a collision, and so no communication is possible. Transceivers can be connected to cable segments within connectors or via a vampire tap, which allows new nodes to be added while existing connections are live. Properties: maximum length of each thick Ethernet segment is 500 meter. Maximum of 100 nodes can be connected in each segment. Transceivers may be installed only at precise 2.5 meter intervals. Advantages: excellent noise immunity, superior mechanical strength. Disadvantages: transceiver boxes are more expensive. Wiring represented a significant part of total installed cost. Unshielded Twisted Pair (UTP). In this video, we are going to learn about Unshielded Twisted Pair (UTP). UTP is a set of twisted pairs of cable within a plastic sheet. UTP is ordinary telephone wire and it is the least expensive of all transmission media commonly used for LAN. There are 5 categories in UTP cables, in which category 1, that is Cat 1, as the lowest quality, and category 5, that is Cat 5, as the highest quality. Category 3 and category 5 UTP are commonly used in computer networks, and the difference between them is the number of twists in the cable per unit distance. UTP can transfer data at 1 to 100 Mbps over a distance of 100 meters. This is the least expensive of all the transmission media commonly used for LAN and is easy to work with and simple to install. Category 3 and Category 5 UTPs are commonly used in computer network. UTP can transfer data at 1 to 100 Mbps over a distance of 100 meters. The standard connector for unshielded twisted pair cabling is an RJ45 connector. This is a plastic connector that looks like a large telephone style connector. A slot allows the RJ45 to be inserted only one way. RJ stands for registered jack, implying that the connector follows a standard borrowed from the telephone industry. Use of each category is as follows. Category 5 is used in local area network. It supports up to 100 Mbps transmission speed. Category 4 supports data transmission speed up to 16 Mbps and 3 twists per foot. Category 3 supports data transmission speed up to 10 Mbps and at least 3 twists per feet and used in telephone system. Category 2 supports data transmission speed up to 4 Mbps and suitable for voice data transmission. Category 1 is mostly used in telephone system. Cat 1 is suitable for voice and low-speed data communication. Characteristics of UTP cable. UTP has the following characteristics. Transmission rate of 10 to 100 Mbps. UTP is less expensive than FOC and coaxial cable. Maximum cable segment of UTP is 100 meters. UTP cable is very flexible and easy to work. UTP uses RJ45 connector. Most susceptible to electrical interference or crosstalk. Advantages of UTP cable. UTP is easy to terminate. Cost of installation is less. Disadvantages of UTP cable. It is very noisy. UTP suffers from interference. Shielded Twisted Pair, that is STP. In this video, we are going to learn about Shielded Twisted Pair, that is STP. STP is a cable originally developed by IBM for token ring. They are not commonly used in networks. STP offers a protective sheathing around the copper wire. It consists of a foil or braid shield inside the outer jacket covering all wires. STP Shielded Twisted Pair Cable is a cable originally developed by IBM for token ring that consists of 2 individual wires wrapped in a foil shielding that helps to provide a more reliable data communication. STP, Shielded Twisted Pair, offers a protective sheathing around the copper wire. Distance is limited from 100 meters to 500 meters. STP suffers from outside interference but not as much as UTP. Shielded Twisted Pair cable is available in 3 different configurations. Each pair of wires is individually shielded with foil. There is a foil or braid shield inside the jacket covering all wires. There is a shield around each individual pair as well as around the entire group of wires, referred to as double shield twisted pair. Advantages: less susceptible to electrical interference caused by nearby equipment or wires. STP wire can carry data at a faster speed. Cheaper and far easier to install. It provides better performance at lower data rates. Disadvantages: STP wire is that it is physically larger and more expensive than twisted pair wire. STP is more difficult to connect to a terminating block. Coaxial cables. In this video, we are going to see about coaxial cables. Coaxial cable is made up of 2 conductors that share the common axis. It consists of a hollow outer cylindrical conductor that surrounds a single inner wire conductor. Coaxial cable is used to transmit both analog and digital signals, and its transfer rate is between TP and fiber optic cable. A typical data rate for today's coaxial network is 10 Mbps. Although potential is higher, it suffers from attenuation. Data transfer rate of coaxial cable is between TP and fiber optic cable. Following are some coaxial cable commonly used in networking. 50 ohm RG8 and RG11 for thick Ethernet. 50 ohms RG58 used for thin Ethernet. 75 ohms RG59 used for cable TV. 93 ohms RG62 used for RCNET. The 2 types of coaxial cabling are thin coaxial, thick coaxial. Thin coaxial cable. Thin coaxial cable is also referred to as thin net. The maximum segment length of thin coaxial cable is 185 meters. Thin coaxial cable has been popular in school networks, especially linear bus networks. 10-2 refers to the specification for thin coaxial cable carrying Ethernet signals. The 2 refers to the approximate maximum segment length being 200 meters. In actual fact, the maximum segment length is 185 meters. Thin coaxial cable has been popular in school networks, especially linear bus networks. Thick coaxial cable. Thick coaxial cable is also referred to as thick net. Thick coaxial cable has an extra protective plastic cover that helps to keep the moisture away from the center conductor. The maximum segment length of thick coaxial cable is 500 meters. Thick coaxial cable has an extra protective plastic cover that helps to keep the moisture away from the center conductor. This makes thick coaxial a great choice when running longer lengths in a linear bus network. Characteristics of coaxial cable. 10 Mbps is the transmission rate. Maximum cable length for thin net is 185 meters and for thick net is 500 meters. Flexible and easy to work with thin net. Ethernet designation to 10/2 that is thin net or 10/5 that is thick net. Less expensive than fiber optics cable but more expensive than twisted pair. Good resistance to electrical interference. Applications of coaxial cable. Coaxial cable is used in analog and digital data transmission. A typical data rate for today's coaxial network is 10 Mbps. Although potential is higher, it suffers from attenuation. Coaxial cable is used in telephone networks. It is also used in Ethernet LANs. Advantages: it has higher bandwidth and easy to handle. It is used for longer distance at higher data rates. Excellent noise immunity. Disadvantages: distance is limited. Number of node connection is limited. Proper connectors and termination is must. Fiber optic cables. In this video, we are going to learn about fiber optic cables. A fiber optic cable is a light pipe which is used to carry a light beam from one place to another. Light is an electromagnetic signal and can be modulated by information. Advantages of fiber optic cable. Interior parts of optical fiber or jacket, buffer, cladding and core. The inner core is surrounded by cladding, a layer of glass that reflects the light back into the core. At the destination, light rays get converted into signal again by using receiver. The modulated light travel along the fiber and at the far end are converted to an electrical signal by means of a photoelectric cell. Thus, the original input signal is recovered at a far end. The frequency of light is extremely high, hence it can accommodate wide bandwidth of information. Also, higher data rate can be achieved with excellent reliability. Advantages of fiber optic cable. Wide bandwidth. The light wave occupies the frequency range between 2 into 10 power 12 Hz to 3.7 into 10 power 12 Hz. Thus, the information carrying capability of fiber optic cable is much higher. Low losses. Fiber optic cables offers less signal attenuation over long distances. Typically, it is less than 1 decibel per kilometer. Immune to crosstalk. Since fiber optic cables are non-conductors of electricity, hence they do not produce magnetic field. Thus, fiber optic cables are immune to crosstalk between cables caused by magnetic induction. Interference immune. Fiber optic cables are immune to conductive and radioactive interferences caused by electrical noise sources such as lightning, electric motors, fluorescent light. Lightweight. As fiber cables are made of silicon glass or plastic, which is much lighter than copper or aluminum cables. Lightweight fiber cables are cheaper to transport. Small size. The diameter of fiber is much smaller compared to other cables. Therefore, fiber cable is small in size, requires less storage space. More strength. Fiber cables are stronger and rugged, hence can support more weight. Long distance transmission. Because of less attenuation, transmission at a longer distance is possible. Disadvantages of fiber optic cable. High initial cost. The initial installation or setting up cost is very high compared to all other systems. Maintenance and repairing cost. The maintenance and repairing of fiber optic system is not only difficult but expensive also. Types of fiber optic cables. In this video, we are going to learn about types of fiber optic cables. Types of fiber optics. There are 3 varieties of optical fibers available. All 3 varieties are constructed of either glass or plastic or a combination of glass and plastic. The 3 varieties are plastic core and cladding, glass core with plastic cladding often called as PCS fiber, plastic clad silica, glass core and glass cladding often called as SCS fiber, silica clad silica, plastic core and cladding. Plastic fibers have several advantages over glass fibers. First, plastic fibers are more flexible and consequently more rugged than glass. They are easy to install, can better withstand stress, less expensive, and weigh approximately 60% less than glass. The disadvantages of plastic fibers are their high attenuation characteristic. They do not propagate light as efficiently as glass. Consequently, plastic fibers are limited to relatively short runs, such as within a single building or a building complex. Glass core with plastic cladding. Fibers with glass cores exhibit low attenuation characteristics. However, PCS, plastic clad silica fibers are slightly better than SCS, that is silica clad silica fibers. Also, PCS fibers are less affected by radiation and are therefore more attractive to military applications. Glass core and glass cladding. SCS fiber has the best propagation characteristics and they are easy to terminate than PCS fibers. Unfortunately, SCS cables are the least rugged and they are more susceptible to increase in attenuation when exposed to radiation. The selection of a fiber for a given application is a function of specific system requirements. There are always trade-offs based on the economics and logistics of a particular application. Mode of fiber. Fiber cables can also be classified as per their mode. Light rays propagation as an electromagnetic wave along the fiber. The two components, the electric field and the magnetic field, form patterns across a fiber. These patterns are called as modes of transmission. The mode of a fiber refers to the number of paths for the light rays within the cable. According to modes, optic fibers can be classified into 2 types. Types of fiber optic cable: single mode fiber, multi-mode fiber, step index, graded index. Single mode fiber. In single mode, fiber has a center hole that is sufficiently small so that there is essentially only one path for light ray to pass through the cable. The light ray is propagated in the fiber through reflections. It allows propagation of light ray by only one path, and multimode fiber allows multiple paths for light ray to propagate. The number of modes n is given by the formula n is equal to 1 by 2 pi d by lambda into the square root of n1 square minus n2 square, where d is the diameter of core, n is the numerical aperture, lambda is the wavelength of light ray. Multimode fiber. In multi-mode, light waves are dispersed into numerous paths or modes as they travel through the cable's core. Step index. Step index multimode fiber has a large core where some of the light rays that make up the digital pulse may travel a direct route, whereas others zigzag as they bounce off the cladding. It is easy to manufacture. Its core diameter is 50 to 1000 micrometer, that is large aperture, and allows more light to enter the cable. Graded index. Graded index multimode fiber contains a core in which the refractive index diminishes gradually from the center axis out towards the cladding. The light ray is propagated through the refraction. This cable is mostly used for long-distance communication. Characteristics of fiber optic cable. Fiber optic cable has the following characteristics. Transmission rate of 100 Mbps, not affected by the electrical interference. Most expensive cable. FOC support cable length of 2 km or more. Application of fiber optic cable. It is used for long distance transmission across ocean. Due to low rate of bit error and noise-free transmission, optical fiber is used for long-distance transmission across ocean. Used for broadband internet services because it is last longer than copper cables. Fiber optic cables are expensive to install but last longer than copper cables, and so it is used for broadband internet services. Cat5 structured cable. In this video, we are going to learn about Cat5 structured cable. Category 5 cable, that is Cat5, is a twisted pair cable for carrying signals. The cable standard provides performance of up to 100 MHz and is suitable for 10 base T, 100 base TX, that is fast Ethernet, and 1000 base T gigabit Ethernet. This cable is commonly connected using punch-down blocks and modular connectors. Maximum cable segment length. The maximum length for a cable segment is 100 meter per TIA EIA 568 5A. If longer runs are required, the use of active hardware such as a repeater or switch is necessary. The specifications for 10 base T networking specify a 100 meter length between active devices. Cat5 cable standard. Most Category 5 cables are unshielded, relying on the balanced line twisted pair design and differential signaling for noise rejection. Cat5 can handle 10 by 100 Mbps speeds, fast Ethernet at a frequencies up to 100 MHz bandwidth. Cable types. Connected types and cabling topologies, often referred as RJ45, are used for connecting Category 5 cable. Advantages of Cat5 cable. Cat5 cable offers high transfer speeds. Cat5 cable can transmit up to 4 different signals at a time. It is the cheapest option for networking cable. Disadvantages of Cat5 cable. Cat5 cable is highly sensitive to interference. It is not as effective for larger corporate networks. Cat6 structured cable. In this video, we are going to learn about Cat6 structured cable. Cat6 cable is the latest and best performing version of structured cablings available. Cat6 cable has more stringent specifications for crosstalk and system noise. It is suitable for fast Ethernet, Gigabit Ethernet and 10 Gigabit Ethernet. Compared with Category 5 and Category 5E, Category 6 features more stringent specifications for crosstalk and system noise. The cable standard provides performance of up to 250 MHz and is suitable for 10 base T, 100 base TX, that is fast Ethernet, 1000 base T or 1000 base TX, that is Gigabit Ethernet, and 10 base T, that is 10 Gigabit Ethernet. Maximum length of Cat6 when used for 10 or 100 or 1000 base T, the maximum allowed length of a Cat6 cable is 100 meters or 328 feet. This consists of 90 meters, that is 300 feet, of solid horizontal cabling between the patch panel and the wall jack, plus 10 meters, that is 33 feet, of stranded patch cable between each jack and the attached device. Since stranded cable has higher attenuation than solid cable, exceeding 10 meters of patch cabling will reduce the permissible length of horizontal cable. Characteristics: UTP is a set of twisted pairs of cable within a plastic sheet. Cat6 cabling supports frequencies up to 250 MHz. The maximum allowed length of a Cat6 cable is 100 meters or 328 feet. The wire pairs must not be untwisted and the outer jacket must not be stripped back more than 0.5 inch, that is 12.7 mm. Advantages: the greater performance makes it possible to use with a fast Ethernet network. It can produce double the bandwidth of the Cat5 cables. Disadvantages: the Cat6 cable is more expensive. The Cat6 cable can yield full speed only if every single component in the network can work at gigabit speed. Crimping. In the following video, we are going to learn about crimping. Crimping is the process where the cable is stripped and the wires are placed into metal terminal. Uses: crimping is most extensively used in metalworking. Crimping is commonly used to fix bullets in their cartridge cases, for rapid but lasting electrical connections, securing lids on metal food cans, and many other applications. Because it can be a cold working technique, crimping can also be used to form a strong bond between the workpiece and a non-metallic component. Sometimes, a similar deformity created for reasons other than forming a joint may also be called a crimp. Parts of crimping tool. Tools required for crimping: cable, crimping tool, connector. Process of crimping. Step 1. Stripping the cable. Put the cable inside the tool and remove the outer covering of the cable, exposing the color wires. Step 2. Separating the colored wires. Separate the color pair of wires. Now, straight the color wires so that the twisted cables are smooth. Connection guide. Step 3. Arrange the cables as per the connection guide. 1. Green or white. 2. Green. 3. Orange or white. 4. Blue. 5. Blue or white. 6. Orange. 7. Brown or white. 8. Brown. Step 4. Leveling the rough edges. Step 5. Put the cable inside the connector. Step 6. Crimping the connector. Put the connector inside the crimping tool and press the tool until the connector is properly crimped. Now the cable is ready. Repeater. In this video, we are going to learn about repeater. A repeater is an electronic device that simply regenerates the signal. Dual wireless amplifiers, dual low noise amplifiers, dual external high gain antennas. Repeater receives a signal before it becomes too weak or corrupted and regenerates the original bit pattern and sends the refreshed signals. Repeaters are used to amplify signal, and it is actually a signal regenerator. A digital device that amplifies, reshapes, retimes, or performs a combination of any of these functions on a digital input signal for retransmission. Repeaters are used in offices and large homes. In office, repeater is installed between two segments of LAN and acts as a two-port node. A repeater placed on the line before the legibility of the signal become lost. The repeater extends the length of the LAN segment, provide the long-distance communication. In home or office network, internet connection will extend only small area with modem. A repeater that receives a signal and retransmits it at a higher level or higher power or onto the other side of an obstruction so that the signal can cover longer distances. Usage. Repeaters are used to increase the range of a transmitted signal by retransmission. An optical communication repeater receives light as input and outputs light. The output signal power source is external to the input power, but the output power may be driven by input power. Radio repeaters are used in radio communication services such as commercial or amateur video. A radio repeater consists of a radio receiver connected to a transmitter. The radio signal is received, amplified, and retransmitted usually on a different frequency. Higher radio frequencies are limited to line-of-sight transmission. Their range is blocked by mountains and the curvature of the earth. So, repeaters are located on hills and mountains to retransmit the signal beyond the obstruction. Radio repeaters are also extensively used in broadcasting. Repeaters can be classified into two categories: local repeater, remote repeater. Local repeater. Local repeaters are used to connect LAN segments separated by a very small distance. Remote repeater. Remote repeaters are used to connect LAN segments that are far from each other. A transmission line known as a link segment is provided between two remote repeaters. Applications. Repeaters are used in radio communication, subways and tunnels, vehicles. Radio communication. Radio repeaters are used in radio communication services such as commercial radio. Higher radio frequencies are limited to line-of-sight transmission. Their range is blocked by mountains and the curvature of the earth. So, repeaters are located on hills and mountains to retransmit the signal beyond the obstruction. Subways and tunnels. In tunnels, Donor antennas are located on both the ends of the tunnel. Signals received from the BTS are amplified and then projected into the tunnel through the service antenna, providing coverage to the length of the tunnel. Vehicles. The basic setup of a cell phone repeater is to have an external antenna placed in the area which has good signal. The internal antenna takes the repeated signal and broadcasts it to the area which is not receiving cell phone signal. Advantage: makes it easy to expand a network over a large distance. Connection between various types of media, for example, fiber optic, UTF, coaxial cable, is possible. Traffic cannot be filtered to ease congestion. A repeater cannot work across multiple network architectures. Disadvantage: a repeater cannot work across multiple network architectures. Bridges. In this video, we are going to learn about bridges. A bridge is a connecting server which connects two or more local area networks together. Bridges reduce the amount of traffic on a local area network LAN by dividing it into two segments. Bridges are relatively simple and efficient traffic regulators. However, in most networks, they have been replaced by hubs, switches, and routers. Bridges operate at the data link layer, that is layer 2 of the OSI model. Bridges inspect incoming traffic and decide whether to forward or discard it. Bridges serve a similar function as network switches that also operate at layer 2. Traditional bridges, though, support one network boundary, that is, accessible through a hardware port, whereas switches usually offer 4 or more hardware ports. Switches are sometimes called multi-port bridges for this reason. Types of bridges. There are 3 types of network bridging technologies: transparent bridging, translational bridging, source route bridging. Transparent bridging. The simplest type of bridge is the transparent basic bridge. It stores the traffic until it can transmit it to the next network. The amount of time the data is stored is very brief. Traffic is sent to all ports except the port from which the bridge received the data. No conversion of traffic is performed by a bridge. In this type, the bridge is similar to a repeater. A transparent bridge is invisible to the other devices on the network. Transparent bridges perform only the function of blocking or forwarding data based on the MAC address. The devices on the network are oblivious to these bridges' existence. Transparent bridges are by far the most popular types of bridges. Translational bridging. A translational bridge can convert from one networking system to another. Translational bridges are useful for connecting two different networks such as Ethernet and token ring networks. Depending on the direction of travel, a translational bridge can add or remove information and fields from the frame as needed. Source route bridging. Source route bridges were designed by IBM for use on token ring networks. The source root bridge derives its name from the fact that the entire root of the frame is embedded within the frame. This allows the bridge to make specific decisions about how the frame should be forwarded through the network. The diminishing popularity of token ring makes the chance to work with the source root bridge, which is very low. Routers. In this video, we are going to learn about routers. Routers are devices whose primary purpose is to connect two or more networks and to filter network signals so that only desired information travels between them. Routers operate primarily by examining incoming data for its network routing and transport information. When a data packet comes in one of the lines, the router reads the address information in the packet to determine its ultimate destination. Routers perform the traffic directing functions on the Internet. A data packet is typically forwarded from one router to another through the networks that constitute the Internet network until it reaches its destination node. The most familiar type of routers are home and small office routers that simply pass data such as web pages, email, IM, and videos between the home computers and the Internet. An example of a router would be the owner's cable or DSL modem, which connects to the Internet through an ISP. Applications of routers. In this video, we are going to learn about applications of routers. When multiple routers are used in interconnected networks, the routers exchange information about destination addresses using a dynamic routing protocol. Each router builds up a table listing the preferred routes between any two systems on the interconnected networks. Control plane, forwarding plane, access, distribution, security, core, internet connectivity and internal use, edge router, subscriber edge router, inter-provider border router, control plane. It does this using internal pre-configured directives called static routes or by learning routes using a dynamic routing protocol. A router records a routing table listing what route should be used to forward a data packet and through which physical interface connection. Static and dynamic routes are stored in the routing information base, that is RIB. The control plane logic then strips the RIB from non-essential directives and builds a forwarding information base, that is FIB, to be used by the forwarding plane. Forwarding plane. The router forwards data packets between incoming and outgoing interface connections. It routes it to the correct network type using information that the packet header contains. It uses data recorded in the routing table control plane. Access. Access routers, including small office or home office, that is SOHO models, are located at customer sites such as branch offices that do not need hierarchical routing of their own. Typically, they are optimized for low cost. Some SOHO routers are capable of running alternative free Linux-based firmwares like Tomato. Distribution. Distribution routers aggregate traffic from multiple access routers either at the same site or to collect the data streams from multiple sites to a major enterprise location. Distribution routers are often responsible for enforcing quality of service across a WAN, so they may have considerable memory installed, multiple WAN interface connections, and substantial onboard data processing routines. Security. External networks must be carefully considered as a part of the overall security strategy. A router may include a firewall, VPN handling, and other security functions, or these may be handled by separate devices. Core. In enterprises, a core router may provide a collapsed backbone interconnecting the distribution tier routers from multiple buildings of a campus or large enterprise locations. They tend to be optimized for high bandwidth but lack some of the features of edge routers. Internet connectivity and internal use. Routers intended for ISP and major enterprise connectivity usually exchange routing information using the Border Gateway Protocol. Edge router. Edge router is also called a provider edge router, is placed at the edge of an ISP network. The router uses external BGP to eBGP protocol routers in other ISPs or a large enterprise autonomous system. Subscriber edge router. It is also called a customer edge router, is located at the edge of the subscriber's network. It also uses eBGP protocol to its provider's autonomous system. Inter-provider border router. Interconnecting ISPs is a BGP protocol router that maintains BGP sessions with other BGP protocol routers in ISP autonomous system. What is network topologies? In this video, we are going to learn about network topologies. A network is a set of devices interconnected by a communication medium. Each device is referred to as a node. A node can be a computer, printer, or any other computing device. The manner in which nodes are geometrically arranged and connected is known as a topology of the network. Physical topology of a local area network should have the following desirable features. The topology should be flexible to accommodate changes in physical locations of the stations, increase in the number of stations, and increase in the land geographic coverage. The cost of physical media and installation should be minimum. The network should not have any single point of complete failures. Types of topologies in network: bus topology, ring topology, star topology, mesh topology. Bus topology. In this video, we are going to learn about bus topology. Bus topology, also called horizontal topology. In bus topology, multiple devices are connected one by one by means of a single cable. Bus is passive topology because it requires termination. The central cable is the backbone of this network and is known as a bus. When one computer sends a signal up the wire, all the computers on the network receive the information, but only one accepts the information. The rest discard the messages. Advantages: easy to use and easy to install. Needs fewer physical connectivity devices. A repeater can also be used to extend a bus topology network. Low cost. Disadvantages: Heavy network traffic can slow a bus considerably. It is difficult to troubleshoot a bus. Failure of a cable affects all devices on the network. Difficult to add new node. Star topology. In this video, we are going to learn about star topology. A star topology consists of a number of devices connected by point-to-point links into a central hub. In star topology, every node, that is computer workstation or any other peripheral, is connected to a central node called a hub or switch. A star network consists of one central switch, hub or router, which acts as a conduit to transmit messages. All peripheral nodes may thus communicate with all others by transmitting to and receiving from the central node only. Advantages: it is easy to modify and add new nodes to a star network without disturbing the rest of the network. Centralization allows the inspection of traffic through the network. Easy to detect faults and to remove parts. Installation and configuration is easy. Failures of any node do not bring down the whole star network. Disadvantages: if the central hub fails, the whole network fails to operate. Each device requires its own cable segment. Requires a large amount of cable to be connected. Token ring topology. In this video, we are going to learn about token ring topology. In a ring topology, each computer is connected to the next computer with the last one connected to the first. Data travel from node to node, with each node along the way handling every packet. The signals travel on the cable in only one direction. Each computer retransmits what it receives. Because a ring topology provides only one pathway between any two nodes, ring networks may be disrupted by the failure of a single link. Ring is an active network. In this, termination is not required. Advantages: cable failures are easily found. Performs better than a bus topology under heavy network load. Does not require a central node to manage the connectivity between the computers. It is quite easy to install and reconfigure, since adding or removing a device requires moving just two connections. Disadvantages: adding or removing nodes disrupts the network. It is difficult to troubleshoot a ring network. Failure of one node on the ring can affect the whole network. Cost of cable is more in ring network. Mesh topology. In this video, we are going to learn about mesh topology. The mesh topology has a link between each device in the network. All nodes cooperate in the distribution of data in the network. A mesh network can be designed using a flooding technique or a routing technique. When using a routing technique, the message is propagated along a path by hopping from node to node until the destination is reached. A mesh network whose nodes are all connected to each other is a fully connected network. Fully connected wired networks have the advantages of security and reliability. Problems in a cable affect only the two nodes attached to it. Mesh networks are easy to troubleshoot. Much of the bandwidth available in mesh configuration is wasted. Rather, they are hybrid mesh networks which contain some most important sites with multiple links. Advantages: data can be transmitted from different devices simultaneously. This topology can withstand high traffic. Even if one of the components fails, there is always an alternative present, so data transfer does not get affected. Expansion and modification in topology can be done without disrupting other nodes. Troubleshooting is easy. Disadvantages: there are high chances of redundancy in many of the network connections. Overall cost of this network way is too high as compared to other network topologies. Setup and maintenance of this topology is very difficult. Even administration of the network is tough. Difficulty of installation. OSI model. In this video, we are going to learn about OSI model. The International Organization for Standardization developed the Open System Interconnection, that is OSI reference model. OSI model is the most widely used model for networking. OSI is a 7-layer standard. The OSI model does not specify the communication standard or protocols to be used to perform networking tasks. Services provided by OSI model provides peer-to-peer logical services with layer physical implementation. Provides standards for communication between systems. Defines point of interconnection for the exchange of information between systems. Each layer should perform a well-defined function. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Narrows the point in order to increase the ability to communicate without expansive conversions and translations between products. Principles used in defining OSI layers. Do not create so many layers as to make the system engineering. The task of describing and integrating the layer is more difficult than necessary. Create a boundary at a point where the description of services can be small and the number of interrelations across the boundary is minimized. Create separate layers to handle functions that are manifestly different in the process performed. Collect similar functions into the same layer. Select the boundaries at a point which past experience has demonstrated to be successful. Create a layer of easily localized function so that the layer could be totally redesigned and its protocol changed in a major way to take advantage of new advances in architecture, hardware, or software technology without changing the services expected from and provided to the adjacent layers. Create a boundary where it may be useful at some points in time to have the corresponding interface standardized. Create for each layer boundaries with its upper and lower layer only. OSI model layers. In this video, we are going to learn about layers of OSI model. OSI layers basically consist of 7 layers as follows. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Physical layer. It is the lowest layer of the OSI model. This layer transmits raw bits over a communication channel. The design issue of physical layer considers 4 factors: electrical, mechanical, procedural attributes, function attributes. The electrical attributes describe the voltage level or current level. The mechanical attributes describe the connectors and the wires of the interface. The procedural attributes describes what connectors must do and the sequence of events required to effect actual data transfer across the interface. The functional attributes describe the function to be performed by the physical interface. Data link layer. It is responsible for the transfer of data over the channel. It groups zeros and ones into frames. A frame is a series of bits that forms a unit of data. DLL detects and corrects the transmission errors using error correction method. It also provides data flow control to ensure that the DTE does not become overburdened. It identifies the devices on the network. Network layer. It specifies the intra-network operations and different types of addressing and routing services. Logical and service addressing are provided from network layer. It also provides switching control and terminal connections. The X25 specification is included in this layer. Transport layer. It is responsible for reliable end-to-end data transfer. Hence, the optimum utilization of network resources occurs. The transport layer performs the service of sending and receiving segments of data to session layer. It also provides flow control, sequence numbering, and message acknowledgement. Session layer. It adds mechanisms to establish, maintain, synchronize, and manage communication between network entities. This layer has specific services, primitives, and protocol data unit which are defined in ISO. Presentation layer. It is responsible for data compression, data expansion, data encryption, and data decryption. It accepts data types int, char, etc. from application layer and then negotiate with its peer layer as to the syntax representation. Application layer. It supports end-user functions like login, password, and file transfer. This layer contains service elements to support application processes such as job management, financial data exchange, and business data exchange. This layer also supports virtual terminal and virtual file concepts. Protocols and network components in OSI layers. In this video, we are going to learn about protocols and network components in OSI layers. OSI layers, protocols, network components. Application layer, DNS, FTP, TFTP, BOOTP, SNMP, RLOGN, SMTP, MIME, NFS, Telnet. Gateway. Presentation layer, SMB, NCP, Gateway. Session layer, NetBIOS, RPC, Gateway. Transport layer, TCP, ARP, RARP, SPX, NW-Link, NetBIOS, NetBEUI. Gateway, B router advanced cable tester. Network layer, IP, ARP, RARP, ICMP, IGMP, IPX, OSFP, RIP, NW-Link, NetBEUL, Decent. Router, B router frame relay device, ATM switch. Data link layer, LLC. Bridge, switch, NIC, intelligent hub. Physical layer, IEEE 802, IEEE 802.2, ISO 2110, ISDN. Repeater, multiplexer, hub, amplifier, oscilloscope. OSI layers with functions. In this video, we are going to see about OSI layers with functions. Open System Interconnection, OSI model, a suggested standard for communication that was developed by the International Organization for Standardization, ISO. Physical layer, media, signal, and binary transmission. It is concerned with transmission of unstructured bit stream over physical medium. It deals with the mechanical, electrical, functional, and procedural characteristics to access physical medium. Data link layer, MAC and LLC physical addressing. It provides reliable transfer of information across the physical link. It sends blocks, that is frames, with necessary synchronization, error control, and flow control. Network layer, path determination and IP, logical addressing. It provides upper layers with independence from the data transmission and switching technologies used to connect systems. It is responsible for establishing, maintaining, and terminating connections. Transport layer, end-to-end connections and reliability. It provides reliable, transparent transfer of data between endpoints. It provides end-to-end error recovery and flow control. Session layer, inter-host communication. It provides a control structure for communication between applications. It establishes, manages, and terminates connections between cooperating applications. Presentation layer, data representation and encryption. It provides independence to application processes from difference in data representation, that is syntax. Application layer, network process to application. It provides access to OSI environment for users and also provides distributed information services. Function of OSI model layers. User A send the information to the application layer which is closest to the end user. That means both the OSI application layer and the user interact directly with the software application. Application layer uses SMTP commands to tell the server how to handle the data. The presentation layer works to alter into a form that the application layer can read. It will format and encrypt the data to be sent over the network. Session layer establishes, manages and ends communication connections between applications. It controls whose turn it is to communicate, and if it is allowed to communicate simultaneously, it will manage things between each node. The transport layer accepts data from the session layer, ensures complete data transfer by breaking it down into things called segments, and sends to network layer. In network layer, segments become packets by adding destination IP address and source IP address. Data link layer encodes and decodes data packets into bits. The encapsulated data, that is packet, is actually placed inside a data frame. The data link layer is responsible for data movement across the actual physical link to the destination node. The frames are converted into a single bit stream as they are passed to the physical layer from the data link layer. This means that bits are queued up one by one as they move on to the network media. What is the need of layers? In this video, we are going to learn about the needs of OSI layer. The simple answer is that a networking system is simpler, cheaper and more reliable if it is implemented in terms of layers. Each layer accepts responsibility for a small part of the functionality. Having a clean separation of function between layers means that multiple layers do not need to duplicate functionality. It also means that layers are less likely to interfere with one another. A simple example, in the TCP/IP protocol suite, the IP layer is very simple. All it does is provide a uniform format for messages to be passed between computers that will work from anywhere on the internet, regardless of what kind of link layer is being used, and provide a uniform addressing model for computers on the internet.